All right, as far as approaching this problem, there's two different ways that you can. And you can approach it by treating it as a complex fraction or by factoring. I'm going to go through both of those methods. And let's start with the treating it like a complex fraction. And in this one, it's conducive to this form because it's actually written in that form anyway. And so if you think of everything in its rational form or fraction form, what you can do is you can get rid of your complex fraction, either method 1 or method 2. Remember, method 1 means to rewrite everything as a single fraction in the numerator and in the denominator, and then invert and multiply. Most students tend to do that, so I'll walk through that method here. But you could also multiply top and bottom by the LCD of everything involved. All right, so let's say we were doing the first method. In that method, you're going to rewrite the entire numerator as a single fraction. We have to establish an LCD. We have a factor of 1, don't need to write anything, and a factor of root x squared minus 1. And so here's our LCD. If we come back to the first fraction's numerator, root x squared minus 1, and we multiply this by the missing LCD factor from its denominator, what's it missing? It's missing the entire thing, root x squared minus 1. So taking root x squared minus 1 and multiplying it by this LCD factor, which is the same thing, repeated multiplication can be abbreviated with a power. So it's like squaring it, and what does the square do with the radical? Cancels. So you're really just left with an x squared minus 1 minus the next fraction's numerator x times the LCD factor that's missing from its denominator. It's not missing anything. Okay, so here is our numerator. We can reorganize our terms slightly. X squared minus x minus 1 all over square root of x squared minus 1. All right, so here is our numerator written as a single fraction. Okay, we're going to do the same thing with our denominator. Do we need to do anything to that? No, it's already written as a single fraction, so we just invert and multiply. So 1 over x squared minus 1. And when we multiply across the top, it's just itself multiplied by 1. And then across the bottom, we have these two common bases. So again, you could write it in this form, but my preference would be go ahead and, if this is the case, combine your like bases and just express it with a rational power. So if we looked at this as a rational power, the square root has a power of what? 1/2. And so we could simplify this into x squared minus x minus 1 all over the common base, x squared minus 1 to the power of, when you multiply exponents, you do what with the powers? Add them, so 2/2 plus 1/2 is 3/2, and you get your solution. Okay. All right, the second method that you could have used for this is the method of factoring. If you're able to factor, oftentimes this winds up being a quicker approach. And if you wind up factoring, what you want to do is you want to convert everything that's written as a radical into rational power form. Right? So if we look at this expression here and we just rewrite everything as a rational power, the square root is a power of 1/2 minus x times here the square root of x squared minus 1 has a power of 1/2, but it's in the denominator, so what else do we need to do to that power? Negative. And then that's all over x squared minus 1. Okay, so if you're going to solve this by factoring, you would look in the numerator. We have two groups of factors. So we're going to remove any common groups. The only base that's common to those is the x squared minus 1. So we're going to take out the smallest power. Which of these powers is smaller, 1/2 or negative 1/2? Further to the left on a number line is negative 1/2. So once we take that common factor out, we're going to be left with something that has the exact same form as the original, one group minus another group. And so let's see what's left. Taking out a power, you divide out. Anytime you divide exponents, you do what with their powers? Subtract it. So we're going to subtract this power of negative 1/2, which is equivalent to adding the opposite. So we get, as our first group, we're left with x squared minus 1 to the 1/2 plus 1/2, or first. Okay. In the second one, when we take out a power of minus 1/2, we subtract that, which is equivalent to adding the opposite, and which in effect takes out that whole factor. We're left with just the minus x. and that's all over x squared minus 1. And so your final step here, to simplify, any bases that have a negative power, we're going to move down below. So this becomes x squared minus 1 to the positive 1/2. Again, when you move it down, it loses the sign or changes the sign. And so our final solution, we just reorganize our terms up top again. And then here in the denominator, we have a common base of x squared minus 1, so we can multiply those. Multiplying exponents with the same base, you add their powers. So 1/2 plus 1 or 2/2 gives you 3/2. We wind up with the exact same thing. And factoring, as you can see here, if you can get the process, it's going to be a little bit quicker and more efficient. And there are going to be some problems on your homework where if you don't factor to start with, it's going to be a real complicated problem that you will eventually need to factor anyway. So you might as well get into the habit of factoring. It makes it easier if you can learn how to do that.